Every single winter, it's the same story. A thick, nasty smog just rolls into the Indo-Gangetic Plain, home to, hundreds of millions of people. But what if the real reason this crisis is so bad isn't just about emissions? What if it's about the very land and the air itself? So today, we're going to break down exactly why this entire region is, well, an almost perfect trap for pollution. This really gets right to the heart of it. It's not just saying the region has a pollution problem, it's saying the region is a natural trap for it. The problem is literally baked into the landscape. It's a place that's almost perfectly designed to capture and hold on to every last particle. So, this is the mystery we're really diving into. Every winter, like clockwork, the smog comes back. Why here? And why is it so incredibly bad? Well, it turns out the answer isn't just about what's being pumped into the air, but about the air's complete inability to get out. So let's frame our little investigation around this question. I mean, emissions are obviously a huge part of the story, no doubt. But could there be a bigger, more powerful force at work here? Something to do with geography and atmospheric physics that just sets the stage for disaster every single year? Let's dig in. Okay, so let's start with the most permanent piece of this puzzle, or this prison, really, the landscape itself. Before we even talk about weather or what's coming out of tailpipes, we have to understand the massive physical container this whole region is stuck in. And here is the first wall of our prison, the Himalayas. We're talking about a massive 2,500-kilometer-long mountain range that acts like an immovable barrier to the north. Polluted air drifts that way, hits this colossal wall, and has absolutely nowhere to go. It just can't get over, which effectively boxes the entire region in. But, physical walls are only part of the story. During the winter, the atmosphere itself creates an invisible ceiling, closing the trap from above. This is what turns the entire plain into a kind of sealed container. It's where the weather itself really turns against the region. The thing responsible for this is called a temperature inversion. Now, normally, air is warmer near the ground and gets colder as you go up. That's what lets pollutants rise and just drift away. But in the winter, the whole system flips on its head. A layer of warmer air gets stuck up high, acting like an atmospheric lid on top of the colder, denser air that we're all living and breathing in down below. So here's how it happens, step by step. First, on a clear winter night, the ground loses heat and cools off, fast. Second, that cools the layer of air right above it, making it colder and heavier than the air above that. Third, that warmer layer up top basically becomes a lid. And finally, with that lid firmly in place, every single bit of pollution from cars, fires, factories, it's trapped. It has no way out. Now, look at this comparison, because it's pretty staggering. In the summer, the air we live in can mix all the way up to 3 kilometers high. That's a huge volume for pollution to spread out and become less concentrated. But in the winter, that space just collapses. The ceiling can drop to less than 200 meters, trapping all of us in this incredibly shallow layer of air. Think about what that actually means. The volume of air we have to breathe in can shrink by up to 95%. It's like taking all the air in a giant stadium and squishing it into a tiny little room. Even if you don't add any more pollution, the concentration just goes through the roof. So you've got the Himalayan walls on the side and the atmospheric lid on top. The final nail in the coffin, the wind just disappears. In the winter, the air often just stops moving. It becomes completely stagnant. There's no breeze to flush the pollution out, so it just sits there, day after day, getting worse and worse. Okay, so we've built our perfect trap. We have the walls, we have the lid, and we have stagnant air. Now let's take a look at the specific ingredients that are getting caught inside it, creating this, toxic soup. So what's actually in this toxic bubble? Well, you start with a base layer of just natural dust from all the dry soil. Then, on top of that, you pile on everything from modern life: vehicle exhaust, factory emissions, cooking fires. And then you get these huge seasonal spikes, like agricultural burning, that just pour even more smoke into an atmosphere that has absolutely no way to clean itself out. And it gets even worse. You see, the pollutants don't just float around by themselves. The damp winter air causes a chemical reaction. They start to clump together with fog and dust particles, creating this thick, soupy smog that literally hangs in the air for days and just refuses to go away. All right, let's put all the pieces together. You have the geographic prison, the atmospheric lid, the stagnant air, and that toxic cocktail of pollutants. So what happens when all of these factors combine? And this is the key takeaway right here. The natural conditions act as a powerful multiplier. The mountains, the inversion, the still air, they don't just add to the problem, they amplify it. A single puff of smoke here is so much more dangerous than it would be almost anywhere else on Earth, precisely because it has nowhere to go.
This really drives the whole point home. The pollution crisis here isn't some kind of fluke. It's a structural outcome built right into the region's geography and its winter climate. In a weird way, the whole system is perfectly designed to fail.
And this leaves us with a really big, really tough question. The mountains aren't moving. The winter weather is always going to come back. So if the trap itself is a permanent feature, how do you possibly fix the problem? Is just managing emissions even enough? Or does this unforgiving reality demand a completely different way of thinking about clean air?